the GeForce FX series. So maligned for its reputation of cut-rate image quality, inferior performance, and at times ludicrous heat production. NVIDIA's impeccable legacy and popularity tarnished by a single product range, fundamentally flawed in its design, and in turn all of it acting as leverage to propel their competitor to new heights, assuming the crown as new king of consumer graphics. This is a story of hubris, miscalculation, and market upheaval. And this is Pixel Pipes. The world of video games was a changed place by the early 2000s. We had already been introduced to the idea of programmable pixel shaders via the GeForce 3 series on the PC, and consequently the original Xbox for home consoles. But as much potential as that idea seemed to hold in store, it was DirectX 9 that promised to deliver the full realization of that idea. True, movie-like rendering in real time. And it was with bated breath that we anticipated the first products to utilize that technology from both ATI and NVIDIA in 2002. For their part, ATI seemed to be right on track. At E3 in May 2002, id Software set up a small theater at the Activision booth and gave the first public reveal of a sequel to one of their oldest and most important gaming franchises, Doom 3. And their hardware of choice for powering it was the much-rumored R300, the core eventually used to create the Radeon 9500 and 9700 series products. Later that year at QuakeCon, near-production-ready samples of the Radeon 9700 Pro were used in a host of LAN gaming computers, amidst John Carmack's praises for the speed and cutting-edge features of ATI's newest architecture. NVIDIA had only promises and missed deadlines. Holding their new GPU hostage was TSMC's brand new 130nm process, a largely untested manufacturing node which was given the overwhelming task of producing NVIDIA's next top-of-the-line chip, intended to pack more transistors running at a higher clock speed than ever before. The unproven process size led to many tapeouts, revisions, and delays. But when the final product finally emerged, it was clear from the industrial cooling solution and retail scarcity that NVIDIA had reached too far. The GeForce FX 5800 Ultra would miss its projected launch in December of 2002, instead releasing in late January the following year with general availability the next month. It was several months late to the competition and could only best the Radeon 9700 Pro by around 10% in ideal cases, while losing by a significant margin in others. The GeForce FX series would continue on with newer iterations throughout 2003. When ATI released their refreshed 9800 Pro, NVIDIA would follow suit with the 5900 Ultra, which corrected many of the faults of the 5800 Ultra with a more nuanced cooler, and a memory bus doubled to 256 bits to match ATI's. ATI would counter with the 9800 XT, and NVIDIA would follow up with the 5950 Ultra, with only minor bumps in clock speeds. It was a cat-and-mouse chase, but no matter what NVIDIA tried, there was one inescapable truth they couldn't outrun. The FX series was touted for its cinematic quality rendering, and NVIDIA even gave it a name, CineFX. This had to do with the 128-bit color capability of their architecture, referring to the floating point color precision of its shader pipes. NVIDIA even developed a shader language alongside the launch of the product line called CG, which was intended to make it easier to develop complex shader code that could be moved between platforms and applications, even sophisticated rendering tools like Maya. In a way, it was a proclamation that NVIDIA's GPUs really were that good now. The FX series feature set was indeed very impressive for its time, going far beyond the requirements of Shader Model 2.0, especially in regards to the number of in-flight instructions supported. The architecture even had aspects of Shader Model 3.0, namely that aforementioned color precision depth, but as it turns out, this same asset would eventually become its biggest weakness. NVIDIA undoubtedly figured it was making a more future-proof decision with its support for 32-bit per-channel floating-point color, but as it turns out, early DirectX 9 games only used the baseline 24-bit color mode required by the API. The FX series could use its 32-bit hardware to run 24-bit effects with no errors or issues, but this caused a tremendous strain on the shader hardware. As described by Derek Wilson of AnandTech back in 2004, much of the performance issues when running shader code on the FX series architecture stemmed from what's called register pressure. This is the temporary space in a processor for keeping code it's currently working on. Running higher precision code, such as 32-bit 4-component color operations, takes up more of this register space than 24-bit would, and the FX series wasn't able to keep its shader ALUs running optimally while constantly swapping out register data due to inadequate space. As a fallback, the FX series could instead run 24-bit operations in 16-bit mode, and perform much closer to its expected level, but this incurred a noticeable degradation of image quality, not executing the 24-bit code as the developer intended, and was instead considered cheating. NVIDIA nonetheless implemented this trick in secret to improve its performance in applications such as 3D Mark 03 and Far Cry. They were caught by users and journalists, and suffered a major loss of trust in the community as a result. Flagship GeForce FX cards were also touted by NVIDIA early on as having 8 pixel pipelines, same as ATI's 9700 Pro. As it turns out, this was another bit of dishonesty by the company, and one more reason why the GeForce FX series struggled to perform as well as its competition. It indeed had 8 texture units and could perform 8 Z-depth and stencil operations per cycle, but was doing so with just 4 pixel pipes, the same number used all the way back to the original GeForce 256. To make matters worse, each of those 4 pipes were considerably weaker and could not perform as many operations as ATI's, whereas R300 could execute up to 4 multiply plus add or MAD operations, and 4 add operations per pipe per clock cycle. NV30 could only do 4 MAD operations. If that weren't enough, the FX series also used an inferior method of multi-sampling anti-aliasing called an ordered grid sampling pattern, which produced inferior-looking results to ATI's rotated grid sampling method. This was not ideal for most stair-step aliasing issues, as a rotated grid will sample color along the edge of angled geometry much more effectively. The problems with the FX series were not confined to a few bad apples. These fundamental architectural issues followed the series all the way down the product line, and in the case of the budget FX 5200 solutions, even more of the optimizations were disabled, leading to even less efficient rendering. As a result, they were considered to be some of the worst cards for the time for playing modern games. The faults of the FX series did not go unnoticed by the PC market, and NVIDIA's profits took a major hit as a result. Their presence in the consumer space was nonetheless expansive, with at least 18 cards across every conceivable price point. It also rectified the most criticized fault of NVIDIA's previous GeForce 4 MX series by supporting all features across the entire stack, whether or not they all had the performance to use them. In the end, NVIDIA's shortcomings during this time led to a surge in sales and market share for their rival ATI, balancing the two forces in the GPU industry and polarizing the community of users, many of whom had jumped wholeheartedly onto the Red Team's bandwagon. NVIDIA went from a company that could seemingly do no wrong to one whose products would be met with some measure of skepticism. and whose image quality must be scrutinized on whether it met the yardstick standard of their competitor. For many, it was the start of a never-ending cycle of mistrust in the graphics giant, which has echoed throughout the years of sponsored the way it's meant to be played titles and the current age of GameWorks effects. Hardware-wise, NVIDIA would spring back ferociously with the very next generation, and aside from a few stumbling blocks here and there, would never have to deal with a hobbling architecture on the level of the notorious GeForce FX series ever again. Thanks for watching. This has been Pixel Pipes.